This is the last question. So, question 10 of Mock A. It's actually a more complicated question than it might seem. It starts off with an admittedly very difficult calculus question, and then it goes into some minimum spanning trees. So, first question, f of x is 2 cos 2x and g of x is 3 sine 2x. Find the constants a and b which satisfy the identity f of x is logically equivalent to a sine squared x plus b. So we know that cos of 2 theta is cos squared theta plus sine squared theta, minus rather. We can replace that with either 2 cos squared minus 1, or the one that we're looking for is 1 minus 2 sine squared theta. So what we get is that 2 cos 2x is 2 times 1 minus 2 sine squared x, rather, not theta, which, when we write it in this form, is minus 4 sine squared x plus 2. So we can write that a is negative 4 and b is 2. Find the value of c in which f of c equals g of c closest to x equals 0. So we can let 2 cos 2x equal 3 sine 2x. If we divide by cos 2x and then divide by the 3, we get 2 over 3. Cos a over sine is tan a, so that we get tan of 2x. If we do tan inverse of 2/3 and then divide by 2, so 1/2 tan inverse of 2/3. We want it in radians. So I'll just retype it because I had it in degrees. 1/2 tan inverse of 2/3. So we get x is 0.29. Oh. Hence, find the magnitude of the area forming fx/gx and the lines x equals c and x equals pi c. So we'll actually just do a little quick sketch of this. 2 cos 2x. Well, we know what cos looks like. Cos starts up and then goes down. So normally, if we do, oh god, what's happening? So that's 2 cos 2x. 3 sine. Now sine will go steeper, and we'll go something like that. So this is where they intersect first. Now pi for this, normally 2 pi represents a full period, but pi in this case represents a full period because of the fact that we have a 2 in front of it. So one full period will land here. So then we'll have x equals c and then x equals pi c. So what's actually meant to happen is that this area here and this area here are meant to be equal. So what we actually want is where they intersect again. So they'll intersect again after pi over 2, because normally they intersect after pi over 4, but here they'll intersect again after pi over 2 plus 0.29. So the total area is just twice the integral between 0.29 and then I'll just approximate pi over 2 plus 0.29, let's say 1.86. So 1.86 of the first graph minus the second. So that's going to be the sine graph minus the cos graph. So we're going to have 3 sine 2x minus 2 cos 2x dx. So we're going to have 2 times 0.29 to 1.86. Sine integrates to minus cos, cos integrates to sine. So we're actually going to have a negative sign pulled out here. So sine integrates to minus cos, but we're going to have to do 3 halves cos 2x. Cos it integrates to sine, so we're going to get a plus because you already factored the minus. This is just going to be sine of 2x. Now just evaluate it. So we're going to get negative 2 I'll factor the negative 2 actually out first. So we'll do 3 halves cos of 2 times 1.86 plus sine of 2 times 1.86 And we get minus 1.8 minus the same thing, but we insert 0.29. So 3 halves cos of 2 times 0.29 plus sine of 2 times 0.29, which is again 1.8. So this is actually 2 times 3 point, so minus 1.8, so it's minus 1.8 minus another 1.8 is 3.6. Twice of that inverted is 7.2 units squared. And that should hopefully be the area bounded by x equals c and x equals pi c, importantly the magnitude. So, this question shows a network of connections between European capital cities by plane, or the way to represent the time in minutes to get there. Network start to scale. Find the time taken to go from Dublin to London to Warsaw to Tallinn. Tallinn being the capital of Estonia. One of the ones that people might not be all too sure about is Sarajevo, which is the capital of Bosnia and Herzegovina. So your reference field. So Dublin to London is 45. London to Warsaw, we can't do. So to Warsaw, we might have to go through Amsterdam because there's no other quick connection. So we're going to have to go through Amsterdam. Then we're going to go to Warsaw, which is 55. And then to Tallinn is another 60. So that's why I added that little trick. And that takes 200 minutes. Obviously, a flight from Dublin to Estonia is not going to take 3 hours, but that's just with all those stops. Now, find the minimum spanning tree for the network. State the name of the algorithm you're using to find said minimum spanning tree. Relevant working must be shown. So, my personal favorite to use is Prim's. So, we're going to use Prim's algorithm. And we're going to start at Dublin. So, I'm going to actually use this graphic. So, we're going to start at Dublin. Now, the quickest out of Dublin is to go to London. So, we're just going to write Dublin to London equals 45. And no cycles will be created. Now, out of London and Dublin, the quickest is to Amsterdam. So that'll be L to A. It's 40. Now, out of that, we have a 45 to Rome. I think that's quickest. So we have a 45 to Rome. So that'll be AR is 45. Now, quickest out of there, we can either go to Paris or to Warsaw. I'm going to go to Paris first. Let's go to Paris. So that'll be AP. Now we can go to Madrid or we can go to Warsaw. Oh, I've screwed up. There's a 40 to Sarajevo. So we went Amsterdam to Rome. So that's fine. So I don't know how I overlooked that. So Amsterdam to Rome, Rome to Sarajevo is actually next. So that'll be RS is 40. That's why it's important to keep track of things. So RS is 40. Now we can go back to our 50s. We can eliminate an arc immediately if we actually go Rome to Warsaw. So we do RW is 50. And then what that does is it actually eliminates this here. So it eliminates WS being a possible connection. So we're looking at this again. It'll have to be Amsterdam to Paris because there's no other 50s there. So Amsterdam to Paris. So AP is 50. Now we're putting it in. And what that does actually as well is that eliminates Paris to Rome because that's a cycle. Uh, Okay, what we've actually inadvertently done as well is eliminate Amsterdam to Warsaw as well, because we can go Amsterdam, Warsaw, Rome, Amsterdam. And that'll go in the loop, so that's eliminated. Uh, we can also eliminate actually this arc and that arc as well, because Amsterdam, Dublin, London, that's a cycle. And then Dublin, London, Amsterdam, Paris to Dublin, that's also a cycle. So those can be eliminated. Paris to Madrid is still fine, so we can select Paris, Madrid, so PM. is 50. What that does eliminates Dublin to Madrid as a cycle. What can we do? We can go Amsterdam to Tallinn. Is the shortest route we considered. We could also actually go Warsaw to Tallinn instead, as that's shorter. So we'll go Warsaw to Tallinn. So that's TW, and that's 60. Now that eliminates this because you can Amsterdam, Rome, Warsaw, Tallinn. That's the cycle. Then you can go Dublin, Tallinn, Amsterdam, London. So that's actually gone as well. I think we've considered every arc. So there's one, two. Okay, actually, let's count the cities. One, two, three, four, five, six, seven, eight, nine. So there should be eight. One, two, three, four, five, six, seven, eight. Perfect. So if you have nine nodes, there should be eight arcs in your spanning tree. Plus 40, plus 50, plus 50, plus 50, plus 60. Total time of 380 minutes. And that there is the middle spanning tree. Is the algorithm you've selected greedy? Explain what's meant by a greedy. So a greedy algorithm, one of the best analogies I read about it, is that it's like a child who eats just whatever they want without having considering what's going to come later. So yes, it considers any route optimal at all stages with no consideration for the future. That's why in question 4 I've listed it as non-greedy because it does consider everything before stating the final result. Now this is where it gets slightly tricky. A couple from Dublin are planning a European trip to visit all the above capital cities. They want to spend a few hours flying. They budget that every half hour spent in the air costs them about €35. They spend the rest of the day in each city before flying out. On the way back, they wait for 2 hours in the airport for each flight. So we have to consider what the quickest route is along here. Uh, they start from Dublin, I think. Yeah, so they start in Dublin, and they want to visit everything. So what's the best way to think about it? So if they go Dublin, London, Amsterdam, and then they go back and forth, that's only 100 minutes. Then they go back and forth that way, and then they have to go back. So this will spend some time pondering this. Uh, okay, so if they go Dublin, London, Amsterdam, Paris, Madrid. So let's see. Dublin, London, Amsterdam, Paris, Madrid. And then back to Paris and then Amsterdam again. Then Paris, then Amsterdam. Then they go Rome, Sarajevo, Rome. And they go Rome, Sarajevo, Rome. And then Warsaw, Tallinn. And then obviously to get back 70, 110, 155. So actually, um, it says to use the minimum spanning tree. It doesn't. Okay. So this is actually where a little quirk comes in, is that if they follow the same route back, they're not actually going to be they're going to be costing themselves more. So actually, we can actually go from Tallinn back to Dublin straight up because we don't actually have to use the minimum spanning tree, as the question doesn't say. Now this is where it'll get slightly long-winded. So they start on September 1st. Now Dublin, London, Amsterdam. So Dublin to London, London to Amsterdam, Amsterdam to Paris, Amsterdam to Madrid. Then Madrid back to Paris, back to Amsterdam. So that's Madrid back to Paris, back to Amsterdam. So that's another 100. And then they go Rome, Sarajevo, Rome. So that's 45, 40, 45. Plus 45 plus 40 plus 45. 45, 40, and 40 actually. So they go to Amsterdam to Rome to Sarajevo back to Rome. So that's 40 and 40. 50, 60, 140. Meaning for their whole trip, time is 660 minutes. which we can conveniently write as 11 hours. Now that is 22 half hours, and 1 half hour they've budgeted is 35, so the cost is 22 times 35, which is 770 euros. And that's the budgeted cost of their trip. Find the date that the couple returned to Ireland, assuming each flight was on time. So they want to spend 2 hours in each airport. So how many airports? You go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So they spend an extra 26 hours. And they spend 1 day in each. So that's 26 days. Plus the time, which is another 11. So the day will be 20. So the total time will be 26 days, 37 hours, which we can write as just 27 days. Taking 24 off of that becomes 13. So 27 days after September 1st is September 28th. Doesn't say what year. Other than the assumption stated in part 5, no whether the holiday can be affected. Pretty much anything here goes. I think I listed one of the possibilities as like weather delays. So due to weather, obviously in certain weather planes can take off. Or even something extreme as like, I don't know, airport gets bombed or something. So pretty much any valid reason there works. And that is the final question of mock exam A.